We're now ready for step 5. We've just calculated the total within and between sum of squares, but we're almost there but not quite, because we want to calculate what's called the mean squares. If you recall, the mean squares is just, in the general terms, it's just a sum of squares divided by the degrees of freedom. So you can think of the variance as a kind of mean squares. It's the sum of squares divided by the degrees of freedom, where the sum of squares is simply each observation in terms of its distance from the overall mean squared divided by the total sample size minus 1. Extending this to one-way analysis of variance, we have 3 different mean squares. The mean squares total is simply the total sum of squares divided by the total degrees of freedom, where the total degrees of freedom is simply the number of observations minus 1. So it's n minus 1. In our particular instance, we have n equals 12, so the degrees of freedom is 11. For the mean squares within, we take the sum of squares within, divide by the degrees of freedom within, where the degrees of freedom within each group is the number of observations, which is 12, minus the number of groups, which is 3, or k. So in our particular instance, you do 12 minus 3, you get a mean squares based on a degrees of freedom of 9. For the mean squares between, we take the sum of squares between and divide by the degrees of freedom between, where the degrees of freedom between is simply the number of groups minus 1, or k minus 1. All we're really doing here is we're saying, okay, we get these total measures of variability, but we want to really calculate sort of an average variability, right? So we divide by the number of independent pieces of information overall, the number of independent pieces of information within each group, and then the number of independent pieces of information between these groups. So in our case, we have the total sum of squares of 143, the between sum of squares of 128, and the within sum of squares of 15. We have 12 observations in 3 groups, or n equals 12 and k equals 3. So the mean squares total is simply 143 divided by 11, which equals 13. The mean squares between is 128 divided by 2, where 2 is calculated based on k minus 1, where k is the number of groups. Since we have 3 minus 1, we have 2 independent pieces of information. And the mean squares within is simply 15 minus 9, or 1.67.